Okay. So understanding common everyday items that compare to some of our most commonly used metric type of measurements. And that way, you know, if you can remember what it compares to, then you should have a good understanding of what that item is in the metric system. All right, and so in the US customary, we have three unique systems when we're measuring length, volume, and mass. In the metric system, it's one system and it works for length, volume, and mass. So we don't have to memorize three different unique random systems. We understand one and can apply it to whatever it is we're trying to measure. So slide number 9. So in order for a measurement to make sense, we now have to make sure with the number that we're including a unit. And Nye had mentioned on Friday that there was a huge miscalculation where it's an international team working on a probe that was going to Mars. And half the team was doing their measurements in the metric system and half was doing it in the US customary. And so when they were combining their work and they were building this probe, obviously those systems don't match up. And so when they went to actually launch the probe, it exploded pretty quickly, and it was like a $125 million project. So huge miscalculation there. But if they had been, and I can't believe that they weren't including units, because obviously if somebody's measuring in millimeters and somebody's measuring in inches, if you had seen that those had units, you would have realized a millimeter and an inch aren't the same thing, right? And so including the unit is massively important. I don't know.
I don't think they just fire people because of that. I mean,
exactly. That's something that's
yeah, I don't know. I mean, I'm guessing that there was definitely some ramification or some kind of, you know, consequence to that. So we're gonna review how the metric system follows base 10. Okay, the US customary, there's no base. Like you have 12 inches to a foot, 3 feet to a yard, right? And then you have 1,760 yards to a mile, 528 feet to a mile, right? That there's no consistency, and that's just looking at the length. Same thing when we look at volume and mass. So here, when we talk base 10s, we're talking tens, hundreds, thousands, or you can think of it as tenths, hundredths, thousandths if we're talking about really small. So basically, it's kind of a matter of just like moving the decimal point, right? You move it to the right, you're making the number bigger. You move it to the left, and you're making that number smaller. All right? And so there's prefixes that go with these value amounts. And those are some of your vocab terms. And so the units of measurements have the base, and that's what we move between. The base is kind of like the actual item, like the type of measurement that we're making. Are we measuring length with the meter? Are we measuring mass with the gram? Or are we measuring volume with the liter? So the meter, the liter, and the gram are going to be our three bases, and then we just put prefixes before those to kind of show how big of the base we're dealing with. Okay, so the base is where the unit starts. I always think of base, think of like games that you play. Tag, well, there's a home base. You're playing baseball, you have first base, second base, third base. Those bases are kind of like points that you try to get to, right? That's kind of like where you're shooting for, or kind of like almost like a safe area or a beginning area. You go from first, and then you go to second, and then from second you have to go to third, right? So the base with our metric system is kind of our starting point, or it kind of lets us know what we're dealing with. From that base, we can have a big version of that, like the kilo, the hecta, or the deca, or we can have a smaller version of that, where we get into those decimal numbers with a tenth, a hundredth, and a thousandth, the milli, the centi, and the deci. Okay, so all we do is put a prefix in front of our base, and that lets you know how big of the base are you dealing with, a big version of it or a teensy tiny version of it. show the large or the small version. Okay, so remember what a prefix means. Where do you find a prefix? Where does it come in the word? At the beginning, right? At the beginning. So, oops, sorry. Comes at the beginning. And so, our base units are the meter, the liter, and the gram. And so all we have to do is put one of our 6 prefixes before it. And then you, again, get an idea. Are we talking about the big version or the small version of that base? So, here we have the meter, the liter, and the gram. These are our 3 bases. I put the centi in front of it to get the centimeter. I put the kilo in front to get the kiloliter, and I put the deca in front to get the decagram. Those are just 3 examples. I could put any of the 6 prefixes in front of any of the 3 bases, and the system works the same way. Sounding familiar? Unfortunately. All right. And so, depending on what we're measuring or what data we need to collect, we might be measuring length. So any version of length is going to be dealing with the meter, and the abbreviation for that is the letter M. Volume is liter. Notice that the abbreviation is capital L. I capitalize it because the lowercase l can look like a number 1. And so if I have a meaning like 11 liters, if I have 11, I have it look like this. And if I have 11 liters, I know this is 11 liters. But if I make that liter, right? That looks like 111, and I don't know 111 what. All right, so we want to make sure that the liter gets capitalized, that L. And then mass is always going to be the gram, lowercase g. So if I need length, it's going to be some version of the meter, volume, some version of the liter, mass, some version of the gram. And all we do is put our prefixes in front of them, and this is the foundation for our metric system. Okay, so here is, on the pen, yeah. So here is our system, our stair step. So here we have, this is kind of our base area. All right, so 1 meter, 1 gram, or 1 liter. From there, I can go up and make it bigger. Notice I'm putting in a 0 at the end. So if this is, the base is always 1. So from 1, I put a 0 at the end to make it a 10. I put 2 zeros at the end to make it 100. I put 3 zeros at the end to make it 1,000. I can go the other way. From the 1, I can basically move the decimal 1 position to the left to get a tenth. So 1 over 10, or the 0.1. Right? Centi means 100th, so 0.01, and milli means 1,000th, 0.001. So all of these are changing by 1 decimal position each stair step. And that's why the order of those prefixes is super important. If you remember kilo, hecto, deca, base, centi, or deci, centi, milli, then you know, you're always just going up by 1 or going down by 1, right? We're not going to do conversions in here this year. We will get to them some next year, and I know Ms. Durkee does them quite a bit when you get into chemistry. We're not going to take the time to do conversions necessarily, but understand, once you have a good understanding of the system, the conversions come pretty naturally to go from like the kilo to the meter, or the milli up to the deci. Okay, so here is the mnemonic trick to help you remember the order of the prefixes. Right, King Henry died unexpectedly drinking chocolate milk. And I know that like Mrs. Ketty says, does she say, or maybe it's Mr. Yossi says, by drinking chocolate milk, King Henry dies by drinking chocolate milk. If any of you had Mr. Yossi, there's different versions of this. What we're focusing on is the KHDU-DCM. And so hopefully by the end of this unit, you might hear that in your head, KHDU-DCM, KHDU-DCM. Kind of gets rhythmic and sticks in your head. Kilo, hecta, deca, the unit or the base, so it can be unexpectedly or by drinking. Unexpectedly is the unit, or if you want to say the base, for our meter, liter, or gram, you can, go with by drinking chocolate milk. If you have a way that you remember this, don't change. Just stick with what you have. You don't have to do it my way. Like I said, there's lots of different variations of this. Claire, I think you were saying, what was Mrs. Ketty's King Henry does? Or somebody?
I think it was Abby.
Oh, it was Abby? Okay.
I think she was saying like how she doesn't like saying die.
Died, so does.
Does drink chocolate. Does
Does, she doesn't have the
This isn't there. Okay. Does drink, yeah, because if she would just be does drink chocolate milk. Anyways, if you have a way that you remember it, go with that, okay? But you do need to know the KHDU-DCM. All right, and so that abbreviation trick is what we're talking about, that King Henry died unexpectedly drinking chocolate milk. And once we know the trick, we shorten it just with the abbreviations, KHDU-DCM. Kilo, hecta, deca, unit, deci, centi, milli. Okay, so we're going to start looking at length. So obviously length is going to be any time when we're measuring height, length, width, all of those, we would use the base of the meter. And there will be a few labs in here where we definitely are going to have to do that. We're going to need to measure maybe in centimeters or meters. All right, so here is where we get into common everyday things that we can compare to some of these metric units. And when you think of those everyday things, it should help you relate to the metric system. So when you think of a millimeter, think of the thickness of a dime. All right, so on a meter stick, each number is a centimeter. So this is 6 centimeters, this is 7 centimeters. And here we show the thickness of a dime. All right, I'm going to switch it over here for a second. All right, so here is my dime. All right, and so you can see it takes up just about one of those spaces. Okay, and so we see that, and we're gonna take a look. If you look at the meter stick, it goes 99 centimeters, and then it says 1 m for 1 meter. So really this is 100 centimeters for the entire meter stick, right? And so, get all the way down here, right? We start at 1 and go all the way down. Now, make sure you are not looking at this side. This is the inch side. It only goes up to 39 inches. A meter stick is 39 and a little bit, 39 and actually over a quarter, probably 3/8. So as we're looking at this, this is not the side we're going to use. We're always going to use a metric side. I will guarantee you there's always one person that when we do some measuring, they will use inches instead of, just because it's the side that looks more familiar, okay? But we are definitely going to make sure that we are using the meter side, right? And so my thickness of a dime And so everybody knows how thick a dime is. So if you can think of a dime, well, then you're thinking of a millimeter, right? On the next part of that slide, it says, if you think of a centimeter, think of like the width of your pinky. So if you look at my pinky, it fits in here, even like my index finger, well, pinky's better, right in here, 91 to 92, 92 to 93. All of these centimeters, my pinky, it's about the same width as the tip of that pinky, okay? So depending, the first time we get meter sticks out, you'll figure out, you'll put your fingers up against the centimeter and you'll see, okay, which one is closest to matching the width of my finger, okay? And so I think all of you know how thick a dime is, thank you. You all know how, like the width of your pinky, right? So that's what you think of with a millimeter, and that's what you think of when you're thinking of a centimeter. Pretty easy. Those are like the go-to common things. Right? And then the height of a doorknob. So it might not be something that you realize, but all doorknobs are the same height. Okay? They all are right at, I mean, it might just be just a fuzz under a meter, right? But you can see they all are, like, doorknobs are all about a meter high. Sometimes, and this probably happens more with girls with our types of shoes, like if I have like big chunky shoes on for school and I am at my counter like getting stuff ready for lunch and stuff for the day, and I already have my school shoes on, like I'm raised up obviously, so like the counter feels like it's a little lower than normal. Same thing with the doorknobs, like I go to reach for the doorknob and like it's just muscle memory, you just reach for the doorknob, like you don't even have to think, oh, is it up here, is it up here, right? It's just automatic. But if my height has changed because of those shoes, like I do notice it, like, oh, I'm a little bit higher. And so it's kind of a weird thing. We get so used to our doorknobs being the same height that you don't really realize that you're so kind of like trained for it to be that height. And that height is the height of a meter, right? So if you can picture how high a doorknob is, you will always know how long or how high a meter is. All right, so that's kind of the everyday item or the trick to remembering doorknobs. Okay, match that with a meter stick and you should be good. Okay, so a kilometer. It's about the length of 10 football fields. So this would be taking our football field and putting it end over end 10 times. All right, the other way is the old high school to State Route 19. All right, so the distance, years ago, Mrs. Johnson, they measured it to see exactly like, okay, how far is a kilometer, right? And so from the old school all the way across to 19, right? That's about a kilometer. But 10 football fields is about that same length as well. So we have a millimeter for a dime thickness. We have the tip of a pinky for the width of a centimeter. We have the height of a doorknob for a meter, and then 10 football fields end to end for a kilometer. Pretty easy items. Okay, volume. So the amount of space that an object takes up, that is the definition of volume. It's also sometimes called capacity. So if you see the word capacity, it's also talking volume. A lot of times capacity, you'll see like in public places, like even like outside of our gymnasium, it says maximum capacity for how many people should safely be in there. You'll see this in elevators a lot too. Like the maximum capacity is usually like 2,500 kilograms or something like that, which is like the safe amount to have in that elevator. But it's basically how much space is the object taking up, right? And so volume is going to be the length, the width, and the height. And so if we're measuring a solid object, and that solid object is regularly shaped, it has a formula. And you should be familiar with that formula, length times width times height. And so because you're dealing with three length units, a length, a width, and a height, you basically also have to multiply, in a way, those units together. The units we consider to be cubed. So if you're measuring in centimeters, you have centimeters cubed. If you're measuring in meters, it's meters cubed. If it's measuring in decimeters, you cube that, right? So any volume for a solid, you will see something to the third power or cubed. And the reason why is because you have three length units. It's three-dimensional, right? So if it's three-dimensional, you have to represent that in the units as well, right? Nobody had ever explained to me, never pointed it out at least, that volume was three-dimensional. I understood that it was three-dimensional, but I didn't, I just memorized that the units were cubed. Didn't really think about why they were cubed, why is it a centimeter cubed or a meter cubed? Didn't put it together until late into high school that, oh, well, it's because you're multiplying three things together. That's why you get the cubed unit. Think of area. What's the formula for area? For a rectangle or a square, what is it?
Length times width.
Yeah, just length times width. You're only taking two dimensions or two sides of that shape to find area. That's why area units are squared. I never put it together. I just memorized square for the area and cubed for volume. But there's a reason why. It's not just random. So volume is cubed, area is squared. Right, so there's a little extra knowledge for you on a Monday morning. All right, if you're measuring liquid, it's very convenient that a 1 by 1 by 1 centimeter cube is exactly equal to 1 milliliter. And my stuff. 1 milliliter is about the tip of this pipette. This is a pipette. It's kind of like an eyedropper or a medicine dropper, but we call it a pipette in science. And this is about a milliliter, the tip of the pipette. It's not a whole lot, okay? And so if I take this 1 milliliter and I have this empty cube, if this is full of liquid, I could put that 1 milliliter into this cube and it would 100% perfectly fill it. Not overflow, not be under it. It would be perfectly filled. Okay, and so if you've ever given vaccinations or medicine to an animal, you'll see on the syringe, on the vial, or excuse me, the syringe, it shows on one side milliliters and on one side it says cc's a lot of times. It's the same thing. And so if you hear someone say cc and you're talking milliliter, it's okay. You're dealing with the same amount because the 1 centimeter cubed is exactly equal to 1 milliliter. And so if we're dealing with a solid, it's the cubed units. If we're dealing with a liquid, we're dealing with some version of the liter. And the way that I remember it, liquid, liter, they both start with L. So anytime you're dealing with a liquid, it's dealing with the liter. And so, like this Aquafina bottle, it is 1 liter. Well, obviously you put liquid in this, right? So the units are going to be the liter. So the base unit is the liter for a liquid. If we're dealing with a solid, the units are going to be some length cubed. And again, try not to memorize this. Try to think of it kind of common sense. Well, if I have a centimeter times a centimeter times a centimeter, my unit's going to be the centimeter to the third power, or cubed. And this also makes it nice if we can use the idea of water displacement to figure out the shape of something that's weird. So if it's not a square or a circle or a cylinder, and we don't have a formula, right, to find that for us, because we have a bunch of formulas for regular solids, even for prisms. All of those have formulas. So we could just measure the length or the height and then plug it into the formula and we can get the volume. But if you have something like, say, my mouse, there's no formula for the mouse, like it's a weird shape. So if this wasn't electronic and I didn't wanna get it wet, like, we could find another way. But I could put this into a graduated cylinder, and that if we have the original volume, and I put the weird, well, here they have a pickle, and put that pickle or cucumber in there, I can see how much the water raises, how much is that water displaced or pushed up by the new object. And so you find the original volume of the liquid, the new volume, and that actually is the volume of the weird shaped object. All right, and so we'll talk about that a little bit more. But that's also what's nice about this relationship is you can use the liquid to find the solid volume because of this equivalency. Okay, so tip of my pipette, a milliliter. And here is my Aquafina bottle for a liter. You've probably seen, and it's weird because we say a gallon of milk or a half gallon, but when we're talking pop or soda, it's liters and 2 liters, right? You could go get a 2 liter from the soda aisle. It's kind of weird that it's like that. I don't know why you don't say I'm gonna go get a half gallon of Pepsi. Sounds weird though, doesn't it? If I say I'm gonna go get a liter of Pepsi or a 2 liter, like, well, yeah, okay, that sounds normal. So some things, again, we do use the metric system. For whatever reason, it's our common. Now, Aquafina is a French, European-based company, and so the top unit that you'll see on the Aquafina bottle, it says 1 capital L, so 1 liter. In parentheses, it has the 1.05 quarts, which is our US customary, but because it's international, you know, the liter is the top measurement that it shows. All right, so when you're thinking of the liter, you think of the Aquafina bottle. Now, a milli is 1,000th of a liter. It's 0.001. So it would take 1,000 of these to make my 1 liter. That's what that means, right? So 1,000 of these to make my liter. All right, and then a kiloliter. It's the amount of liquid that it would take to fill up 4 standard bathtubs. So not like a giant jacuzzi tub, but just your regular old bathtubs. About 4 bathtubs would make a kiloliter. Kilo means 1,000. So it would also be 1,000 of these. This is a liter, take 1,000 of them. That's what that prefix kilo means. And so if I take that, it would be 1,000 of these bottles. I fill 1 tub, fill another tub, fill another tub. At my 4th tub, I would have probably used about 1,000 of these. All right, measuring mass. So the definition is the amount of matter that is in an object. The amount of matter. And matter is anything that has mass and takes up space. So basically everything in our universe is some type of matter. The only thing that's really not is energy. So like light energy, sound energy, heat energy. Those things do not have mass and they do not take up space, so they are not matter. But everything else is, even air, even things that seem very small or very elusive in a way, just because they're so small, it's hard for us to grasp or hold on to. Those things, if it has mass, it takes up any space at all, it's considered matter, even if it's really, really small. And the base unit will be the gram. So we have the meter for length, we have the liter for volume, and we have the gram for mass. Okay, so when you think of a milligram, think of a single grain of salt. So you've all probably eaten like potato chips or pretzels or something salty, maybe popcorn. And if you've ever gotten like that salt on your fingers and you kind of roll it around, that single grain is a milligram. I had mentioned on Friday that our medication, like ibuprofen, you'll see 200 milligram. And so obviously because it's medicine, that is the scientific community, medicine is science. And so our medicines are dosed in grams, milligrams, that version of the measurement. So, milligram would be 200 milligrams would be like 200 grains of salt. Okay, this one I'm sure you'll have no trouble memorizing or remembering. A single M&M is like a gram. One M&M. So if I told you that this is a kilogram of M&Ms, how many individual M&Ms would it take to make this up? You think, Brooke? It'd be 1,000. Because if each M&M is a gram, and I say this is a kilogram of M&Ms, kilo means 1,000. And so I would have to have 1,000 M&Ms in this kilogram bag. And there are. Maybe minus 1 or 2. Yes.
How do you know those exact?
I counted them. Actually, I had somebody count them for me. I was like, I need 1,000 M&Ms in this baggie. They were like, done, got it. They did that. So, 1 M&M is a gram. 1,000 M&Ms would equal that kilogram. So when you're thinking a kilogram, think of this. And I can pass it around so you can feel. That's a kilogram. Don't eat any. They've been touched for other labs. And yeah, they're like old. Okay. And so a kilogram, okay, so one year I was so excited and I was stupid because I did not keep it. I was at the store and they had a 1 kilogram party pack of M&Ms. I was like, that is awesome. And I bought it and I was like, hey, look, it says 1 kilogram. Why it didn't say 2.2 pounds, because that's what it is, it's 2.2 pounds, I don't know. Well, I did not take into account how awesome that was, and I threw the bag away. Like, after we were done using it, we actually, like, I used the M&Ms for other things, and like, I put them in another bag. I haven't ever in the past 8 years found that again. So it must have been like they sent them the wrong shipment of M&Ms and it had like the metric on there instead of, I've never been able to find it again, where it was exactly 1 kilogram. So then I was like, well, at least I know I can make my own kilogram bag. And I did that, obviously. But that was so exciting. And then I was so mad at myself after that when I threw the bag away, and now I can't find them again. We will pick back up with slide, what is this? Oh, and you can see it here, the 1 kilogram. And